Welcome back. So today we are completely shifting gears in this chapter. So now we're going to start talking about some operations we can do with polynomials, other things we can do with them, specifically division. So we're going to talk about how do we divide polynomials. So that's the one thing we haven't really covered yet in this course. So before we do that though, I want to review long division in terms of how you've learned it in the past, back in elementary school. If I want to divide two numbers using the long division process, the first thing I want to look for is how many times can 11 go into 51 without going over. The goal is always to search with how to get as close as you can without going over. And in this case, 11 can go in 4 times to get 44. So I put 4 up top because that's how close I can get. Then I subtract off how close I got. So 51 minus 44, that's going to give me 7. Then I'm going to carry down the 4. So now I need to see how many times can 11 go into 77. Well, without going over, 11 can go in 6 times, giving me 66. So I put that 6 up top, and now I subtract off the 66. So 74 minus 66 leaves me with 8. Well, now 11 can't go into 8. So that means that my process is basically over. All right? Except I'm left with that remainder. So what I do with that remainder is I'm going to say that is 46 and 8 11ths. Any remainder I have to put back underneath the piece that I'm dividing by. So there's a little recap of long division. So let's see, how can I apply that to polynomials? Okay, so for polynomials, it's the same kind of deal, except every step of the way, I'm looking how many times can that first term go into that term. And every single time, what I'm going to be looking for is canceling out a piece of it. Okay, so what can I multiply x by to give me 4x squared? Well, I need to multiply by 4 because right now it's 1x. Then I need to multiply by x to get it to be a squared. So I'm going to be multiplying by 4x. So I'm going to take the whole thing, that x plus 5, and I need to multiply that 4x to it. So that's going to give me 4x squared plus 20x. So that's what I bring here, 4x squared plus 20x. And again, I'm always going to subtract it off to see how close am I getting. You should always eliminate that first term, 4x squared minus 4x squared. That should always be gone, okay? Always you can eliminate that piece. Now 23x minus 20x, that's going to leave me with a 3x. And then I can bring down that negative 16. All right, now I get to play the same game again. I'm going to take that x and see how many times can that x go into 3x. Well, in this case, it's nice because you can just see I just have to multiply x times 3 for it to inevitably cancel off that 3x. So I'm going to put that plus 3 up top. Then I need to multiply that to the whole x plus 5. When I do, I get 3x plus 15. So now I need to take that 3x plus 15 and I need to subtract it off to see how close did I get. Well, 3x minus 3x cancels, again, just like you always want to. You should always be taking a piece of it away. Negative 16 minus 15 is going to give you a negative 31. Now, that polynomial x plus 15, x plus 5, once you're left with a constant, there's nothing else you can do. All right, so that negative 31 is going to be my remainder. So you always put your remainder over whatever it is you are dividing by. And that is going to be what's left after dividing those polynomials. So I realize this is kind of a long process, something I know you saw back in Expo really briefly, but the goal is now, hopefully, we can get you really, really good at it. So I just have a couple more examples to really step you through this to help you get really good at this. So I'm dividing x cubed by x plus 2. So whatever you're dividing by goes on the outside. And then the top of the fraction goes on the inside. So let's start our process. I need to see how many times can x go into x cubed. What can I multiply x by to get it to be x cubed? Well, I need x squared to make those exponents match. So I need to multiply all of that by x squared. And by all of it, I mean that outside piece. Now I distribute it in. X cubed plus 2x squared. So that's what I put over here. And now I subtract it off to see how close did I get. The first piece should always cancel. So 7x squared minus 2x squared, that's going to leave me with a 5x squared. And now I can bring down that next piece. Now I need to play the same game again. I need to figure out what can I multiply that first term by so I can inevitably cancel off the 5x squared. Well, I think you can see that I need a 5 and I need an additional x, so it becomes an x squared. So once I've identified that that's what it takes to make x equal to 5x squared, now I'll multiply that to that x plus 2 to see how close did I get. So this time that's the piece that I get, and now I have to put that here to see how close did I get. The 5x squares cancel off just like they always should. 14x minus 10x leave me with 4x. Then I drag down the plus 3. So now I still have another step I can take with this one. I need to see what does it take to make that x cancel 4x. Well, to get x to cancel 4x, all it needs is a 4. So I put that plus 4 up top. Then I'm going to multiply that into the x plus 2. To get 4x plus 8. That's what I bring down here. So I can subtract it off and see how close I got. Well, 4x minus 4x cancels off just like it should. 3 minus 8 leaves me with a negative 5. And this is a point now there's nothing more that I can do. So since there's nothing more I can do, that negative 5 becomes my remainder. So I put it up top with the others, but it's still being divided by the x plus 2. It is remaining with that piece. So this whole expression here, that is going to represent your answer when you divide those two polynomials. All right. And again, the thing with dividing polynomials with long division, you just have to keep practicing at it until we get really good. So let's do another example. I'm dividing by x minus 3, so that's what I put out front. And then I have this polynomial here. that is being divided. And so now I start this whole process. What does it take to make x cancel 2x cubed? Well, it's going to take a 2, and I need an x squared to make the exponents line up. So I multiply that to x minus 3. That's going to give me 2x cubed minus 6. Oh, need to scoot this over a little bit. I apologize. So we said we have to multiply it by 2x squared to the x minus 3. So when I multiply that, I get 2x cubed minus 6x squared. So that's what I put out here. 2x cubed minus 6x squared. And I have to subtract that off to see how close did I get. 2x cubed minus 2x cubed cancels off just like it should. Negative 2x squared minus a negative 6x squared. Remember, when you're subtracting a negative, that's basically the same as adding. So this is really negative 2x squared plus 6x squared. It's going to leave me with a positive 4x squared. Then I bring down the next term. Now I focus on getting that x to cancel my 4x squared. So to cancel a 4x squared, I need a 4, and then I need one more x to make it cancel. I'm sorry, I forgot to put that first term up there. So 2x squared. Now I need a positive 4x, and I need to multiply that to the x minus 3. So I distribute that through 4x squared minus 12x. So that's what I bring here, 4x squared minus 12x. 4x squared minus 4x squared cancels off. Negative 5 minus a negative 12. Remember, subtracting a negative is the same as adding, so negative 5 plus 12 is going to give me a 7x. And then drag down the next term. So one last time, what do I need to multiply x by to give me 7x? Well, that's going to take a 7 to get those to line up. And I need to multiply to the whole x minus 3. So I distribute that, so I get 7x minus 21. So that's what I put here. And now I subtract to see how close am I getting. 7x minus 7x cancels just like it should. 7 minus a negative 21. Like we've done multiple times in this problem, when I'm subtracting a negative, it's the same as adding. So I'm left with a 28. I forgot to put that plus 7 up there. I apologize. And then that 28 is the end of our story. When you just have that constant, that is going to be your remainder. So I have a remainder of 28 that's still being influenced by that x minus 3. And that is going to be my solution when I divide those two polynomials. One last example that I need to show you before I let you go in this video. What I need you to understand is when there's a missing piece in the polynomial. So here we have x minus 8. But then we have a piece missing. I have x squared, but I don't have an x term. What I need you to do when you're missing a term anywhere in the polynomial, I need you to represent it with a 0, just showing that there's nothing there. Because that's the only way to get it to line up nicely is if you make sure that you include that hole. So you need to fix that hole with a 0. And now we go through and do everything just like we have been, just again making sure you remember to put that 0 there. So what does it take to make x cancel with an x squared? Well, all it's missing is an x. times x minus 8 is going to be x squared minus 8x. I subtract off to see how close I got. Well, x squared minus x squared leaves me with nothing. That cancels off. 0 minus a negative 8. Again, subtracting a negative. 0 plus 8 gives me 8x and minus 74. What does it take to get x to cancel 8x? Well, that's just going to be an 8 that I need. Distribute that, you get 8x minus 64. So that's what I'm going to put over here. Subtract them to see how close you got. 8x minus 8x, that should always cancel out. The goal is you're eliminating one piece at a time. Negative 74 minus a negative 64. Again, subtracting a negative is the same thing as adding. So negative 74 plus 64 is still going to leave you with a negative 10. I forgot to put that plus 8 piece up there. But then this is the end of our story because we're down to that constant. So again, that constant is always our remainder. So we put it over the piece that's doing the dividing. And that's going to be what's left when you divide those two polynomials. So I realize these notes got really long, a lot of material in here, but I do need you still to take a moment and write that summary for me. Write about what you remember about long division, okay, and what's resynchronizing in your heads as I explained it. So make sure you do that summary, and then please come back ready to do your practice work.